Let's look at the next question in grind 75, valid parentheses. Given a string S containing just the characters open and close, parentheses, curly brace, and square brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Number 2, open brackets must be closed in the correct order. Number 3, every closed bracket has a corresponding open bracket of the same type. So in this example, if we have an open and closed parentheses, that's true. It's a valid set of brackets. And if we could look at the next example, also valid. Each set is open and closed. And if you look at the third example, we are not closing the parentheses, so it is actually false. Constraints are that we're going to have at least one character in the string, and the S is only going to contain open and close, parentheses, square brackets, and curly braces. So when we look at this valid parentheses question, we've got to basically make sure that everything that we open, for example, if we open a square bracket, we've got to make sure it's closed. And also when we close it, it actually is closed with the same kind of bracket. The most intuitive way to solve this is with a stack, or in Swift we might just create an array, and I'll show you how that works. So let's say, for example, our string is open square bracket, open parentheses, open curly, and close curly, close parentheses, and close bracket. How would this work? So if we were to start at the beginning here and loop from left to right through our string, what we're going to do is add this to an array. So our current stack at this point, if we look at this, will be just the opening square bracket. And then we're going to move on to the opening parentheses, and we're going to add that to our stack. And then we're going to look at the opening curly brace right here, and we can see that we're going to add it. So the trend here is if we're adding an opening brace, we're going to go ahead and add this to our stack or array. And then when we close, what we need to do is make sure that whatever is on the top, that has to match the brace. So we can see that an opening curly obviously needs to match with a closing curly. So whenever we see this closing curly, we want to make sure that we get rid of the last closing curly. And if for some reason, let's say there was an opening parentheses or there was nothing in the stack, then we're going to go ahead and error out and say this is invalid. So whenever we close this curly here, in this case, we're going to say, yes, there it is. And then when we get to the closing parentheses, we're going to look at this and go, yep, there it is. We're going to go ahead and remove that. And then when we get to the closing parentheses, we're going to go ahead and remove this. And then after we've finished looping through everything, we want to make sure that there's nothing left in the stack. And then we're going to return, yes, it was valid, or no, it was not valid. The time and space complexity for this are going to be start off with the time. It's going to be a linear solution, O of n, right? Because we have to loop through everything that we're given. And the space complexity is going to be the same thing, because in the worst case, right, we're going to be adding up to half of the braces. And so, yes, you could say, it's going to be n divided by 2 if you're really pedantic, but we actually don't, I'm not sure what the inputs are, but let's just, for simplicity, say it's a constant runtime, or a linear runtime rather. All right, so with that in mind, let's go ahead and look at the code. In Swift, whenever we have string problems, it is often much easier to work through the problem by converting it to an array of characters. So the way that we can do that is by, let's say, creating a variable called cars, and we're going to make an array, and we're going to pass in string. And what this will be instead will be an array of character. And it isn't always required, because yes, you can use string indexes and stuff like that, but for many people, including myself, I find it a little bit more intuitive to work with a normal array. Okay, so from now, we also need to think about that stack that I mentioned. So if we make a stack, and we're going to make this an empty stack of characters. Now what we need to do is loop through our characters. So we're going to say for I in 0 to the cars.count. And now we need to effectively write that logic. But one way that might reduce a lot of our code is we can also allocate a map. And this map is going to be an array of character to character. And what we're going to do with this is write our matching braces. So whenever we encounter, for example, a closing square bracket, for example, the obvious matching one is the opening one. And whenever we encounter a closing curly brace, we might say that the match is going to be the open one. And finally, with the parentheses, we're going to say that whenever we encounter a closing parentheses, the matching parenthesis is going to be the opening parentheses. This will reduce a lot of the duplicate code, but because basically whenever we encounter a character, we don't have to like write a bunch of switch statements that specifically, or if statements to specifically determine if it's the matching bracket. We can just look at our map to see if it matches. Okay, so now what we want to do is we want to switch on cars of I, and we're going to need a few cases. So in the case of any opening bracket, right? So I'll just probably do this in the same way that I declared them. So if we have an opening square bracket, curly bracket, or curly brace, or sorry, parentheses, we're going to go ahead and just simply stack.append our cars of I, and that's that case. And in the case of all the other ones, so we'll say case close parentheses, case close curly brace, case close parentheses. We're going to write some code, but before we write that code, because it's a string, we do need to add a default case. Now we know from the input that it's impossible for this default case to be hit because we've effectively handled every possible case that we're going to get. All right. So what we're going to do here is, yes, whenever we encounter an opening brace, we're going to add it to the stack. But what we need to do is check to see if whenever we pop an element out of the stack, if it's actually the matching brace. So if we were to check our map, right, and we were to pass in cars of I, this will be the matching, or we'll call this the expected opening brace. It's a lot of typing, but it's very clear. So we're going to get the expected opening brace. So for example, if we get the closing square bracket, this will give us the opening square bracket. So if the expected opening brace does not equal to, and again I have to remove the last, so I believe it is stack dot let last character is equal to stack dot remove last. If expected opening brace does not equal to the last character, we know that we basically have not we've not found a valid solution. So, or we've not found a set of characters that have valid opening and closing brackets, to use a term to encapsulate the parentheses, the curly, and the square brackets. And that's going to be that code. And then if we get to the end here, now this function actually does expect a return type. So what I'm going to do is return stack dot is empty. And we're going to submit this code just to see if I got it. Nope, I forgot the in. Okay, so I fixed my problem. So let's actually take a look at what the problem was. So whenever you have an array and you call remove last, as I was, if there's nothing in the stack, what's going to happen is it's going to crash on you. So instead, if you look at pop last in Swift, this will actually give you an optional element and not just crash. So if you try to pop something from the stack and there's nothing there, it actually won't crash on you. So what I've done in the code here is, actually I messed up the indentation, but what I'm doing is the following. I do an if let pop last is equal to stack.pop last. So if I can pop something, give me that character. And if the expected opening brace doesn't equal that, the character that I popped here, the pop last, return false. Otherwise, if we tried to pop something and we couldn't get it off the stack, just go ahead and return false. And that was the main problem. And yes, when you allocate a dictionary inline like this, you don't need to put in the parentheses. But with arrays, for example, you do in this specific case. So I hope that was a help to everybody. And yes, I do struggle with those kinds of small issues as well.